how to OLTP to OLAP archival is handled. Well, we're trying to demystify this project. Let's get connected first for those online and who are here. Generally known as AskDBA, so you can find me online on LinkedIn, Twitter, and other places. You know, for asking questions, connecting, networking, please do connect. Again, my name is ALKIN. I'm from Istanbul, Turkey. I flew a long way around to come over here. This is my first time, so bear with me. And I've been at Enterprise DBA for many years, actually about 15 years. And then I moved on to open source. And I worked previously in PlanetScale, Percona, and Pythian. These are services companies that focus on open source technologies like MySQL, Postgres, MongoDB. And as a technical manager, SRE, and a DBA. And before that, like I said, I've done like large corporation enterprise databases. So I have a pretty good command on Informix, Oracle, and DB2. I was actually one of the SMEs in Informix long time back at this point. And a little bit more about me in this slide. So I also like to sail, and I spent a lot of time on sailing the Mediterranean, and I catch the wind as much as possible. Moreover, I also work from the boat, spent 2-3 months in the season in summer, and this is kind of my little setup over here. I turned my navigation desk into a workstation. We have double internet connection. Starlink is not available yet, and I also wrote a thread about how to work from a sailboat on Twitter. There's a link. I'll share the slides. You can take a look at it. And if anybody wants to talk about sailing, I would be very happy to share some insights about it. And now we get into not the OLTP again. We get into the physics of sailing. Just joking aside, the good illustration of it. A lot of people think the sailing is kind of fun, but there's a lot of things happen when you go out to the sea and you're alone. And what is the most important thing at sea is to come home safely. And that rock right there is the problem, because you have a keel and your displacement is not going to be clear. But what is the next most important thing in the physics of sailing is the beer. Okay. So I also want to talk about something happened recently during February 6th. And we were at another conference, open source conference called FOSDEM. This is the largest conference in Europe in open source area. If you've never heard about FOSDEM, please check it out. Maybe you could actually be there next year. Yes? Is it? Maybe it's the mic is too close. Is it better? Or can you hear me? Yeah. Okay. Yeah, it's picking up something. Okay. So I was talking about. I want to mention the earthquake that happened in Turkey. So I'm from Turkey. It was devastating. These numbers actually you see over here is the same earthquake that felt in different cities around this side of Turkey, between the Turkey and the Syrian border. So yes, we do sit on top of a fault lines, major fault lines. These are called tectonic plates. And the tectonic plate that came from Asia to Africa pushed, and the earth shifted about 6 meters. In feet is about like 20 something feet shifted south. And what happened is around 14 million people impacted, over 50,000 people died. After this earthquake, around 8 hours later, another earthquake hit. So the back-to-back in the same day is very rare. In the last 100 years, that never happened. And then what you can do is you can help Turkey if you have actually maybe click like or share or maybe donate also. I just wanted to make sure that I share this information. It is still ongoing. And the earthquake is not over, because the aftershocks are in very large scale. 6.5, 6.2 still happens, and it's this region is shaking. But we feel also other side effects of these plates moving towards this way. This is Turkey and the Greek border over here, the Aegean Sea. So, and I live over here, which is the very core red active fault line also. And it's difficult to sleep. And I mentioned about myself, and I also co-authored a book called MySQL Cookbook. It has over 250 recipes in MySQL, and my co-author was Sweta, and we have actually handled this book in 2.5 years, recently published in O'Reilly. Why I share this along with this, I have donated all the royalties that's coming from O'Reilly for this year to earthquake victims. So if you happen to buy this book, you will be helping already for the earthquake victims also. And thank you very much for that. So, Amazon, yes, Amazon. It's available on Amazon. Mm-hmm. And this is where I work, a company called Sista Data, and this was founded in 2021. So we are still a startup stage. We got seed investment, and we focus on ClickHouse and infrastructure engineering. We do platform engineering and database engineering. If you've never heard about, anyone heard about ClickHouse before? Okay, ClickHouse, okay. And we do services around products dedicated to ClickHouse and the open source ecosystem. And we have a DBaaS implementation. We do support managed services and do also consulting around. So what is ClickHouse? So some of you know it's a columnar store. It's different than MySQL. And but it is compatible, SQL compatible. You can actually run your most of the SQLs that you can run. It's open source. And it has shared nothing architecture that makes it very, very fast and robust. It does parallel execution on queries and meant for analytics and OLAP systems. And because of that, it has a lot of aggregate functions that may not be available on other databases. And again, repeating this statement, is super fast for analytical workloads. So you don't run transactional systems on it, but you can run others. We will get to that. This is the actually subject of our talk today, why we might need that. About MySQL, it's row-based. I think for those who are in this room might be more familiar with MySQL. Colin and Matthias actually went through some of the MySQL ecosystem. It's a very popular database engine, and it's used by the hyperscalers also. So it's not for only for startups that are using, but it's a very proven technology, 25 years old, and then we have a lot of talks around this MySQL. Colin and I do ecosystem talks around, so you could search online, and you'll get a glimpse of it if you haven't looked into that. So, so today's agenda, what we are going to talk, we're going to talk about analytical workloads on OLTP, which is kind of the purpose of the talk. Analytical data on the OLAP databases, which were meant in that. So what other things that can be done on archiving, streaming, and CDC use case? I'll drill down into these, and then if the demo gods are helpful, we'll do a demo on migrating MySQL data source into ClickHouse, and then we'll compare and contrast these two stores and why are we doing that. So, analytical data on the OLTP database. So it doesn't have to be MySQL. Any OLTP database, Postgres or any other data store, they are seriously unwanted operations. If you've actually managed or was a DBA or SRE or architect in one of those systems, having to do CDC, change data capture, doing all the changes in the database, data warehousing, business intelligence, machine and AI maybe, and also keeping time series data, not even on top of that, logging. Making these operations in OLTP systems sometimes required or forced by the businesses, but not desired. And there are not only the speed and the size and the execution problems, there are also operational problems to keep these databases within your OLTP system. So we always say or advocate to keep our OLTP databases lean and small, so that the scenarios that we just spoke earlier today, failovers, high availability, multi-AZ implementations can be more robust and faster than having these databases very large. So monolithic databases like Oracle or SQL Server is not serving the purpose for our use cases in the most open source implementations, say gaming, say payment systems, e-commerce systems. All these systems that use OLTP databases, open source OLTP databases, they need another solution for OLAP systems. So if we compare the internals of these OLTP, I'm not even saying this is for MySQL, this is true for Postgres and others. I'm saying OLTP because any OLTP system will have a indexing, a B3 indexing, which is actually fast for point lookups and certain queries, but not very good for large data sets and queries that doesn't actually have an index on it. So the more index you have, there's a drawback on the handling of that index, and it leaves pages that actually drills down, and it causes other problems like locking and long transactions. And those are against the OLAP implementation. Analytical processing requires large data sets. The data is usually denormalized, so it comes from multiple sources. And the execution needs to be vectorized so that you could actually mix and match data from different sources or within the same table. And they usually tend to have a better compression. Now the modern OLTP database engines, like Colin mentioned earlier, MyRox has a good compression engine for MySQL, but MySQL's original compression is very basic, and you don't actually get very good result. You get certain result with a certain cost, which is an overhead. Overhead meaning some I/O or CPU slowness or other. So also having these large data sets in OLTP system, maintenance becomes very cumbersome. Meaning you have to add an index, you have to remove an index, you have to add a column. All these operations, even if you can make it using some modern toolkits, try to make them online, they will eventually become a long-running things. I mean, I know adding an index took 27 days. Matthias can give us an examples of weeks of running some online schema changes while the replication is running, while the job is running, so it doesn't fit in the maintenance window. We used to have maintenance windows between 1 a.m. and 5 a.m. Eastern time. That's no longer the case because the applications are open 24/7. People are playing games, people are buying stuff and online ordering, so it's not actually, you don't have that luxury of doing something that is going to be available for maintenance in these large data sets. So going back to what I said on the previous slide, all these implementations, anything that you need in a large data set that actually needs a time series data, you need to log information, don't keep that in your open source OLTP as much as offload it to other data stores that can be much more robust. Yes? What is CDC? I'll get into that a little bit more. It's called change data capture. All the changes that are in the database. We'll talk about that a little bit because we have an example of what is a CDC is. So, so we've been actually thinking about this. There are many, many different implementations. So this is not like a silver bullet or one solution, but this is a good solution that we think, and we've been working on this with my engineering team for the last few months. And then we came to some conclusion that we can actually achieve our long-term goals using some of the open source technologies within the same ecosystem. So, so we have a source database. It could be MySQL or Postgres. We'll talk about that. And then there's a driver that attaches itself to these databases, and then it's called Debezium. And Debezium actually gets, it's an open source, we'll talk about that. And also there's a Kafka. Apache Kafka is a very popular tool, we'll talk about that. And then we drill that into OLTP data source into using Debezium driver to Kafka. And then from Kafka, we turn them into topics, and those topics can be streamed into ClickHouse using a sync connector. So in this case, at Systadata, we've written a sync connector that can actually capture all that information and write it to ClickHouse as a solution in this case. It could be some other column store, but we recommend ClickHouse in this workflow meaningfully and effectively. So talk about Debezium, it's open source, and it's a distributed platform for the change data capture. So the change data capture meaning, when it attaches itself to one of these open source databases, saying, including MySQL, it uses a transaction log. So it reads the transaction log, so it knows all the changes that are coming in the bin logs, the binary logs of MySQL. So from there, it actually starts staging those, and then you could retrieve that information to a destination source. But from our workflow, we need to get in between over here so that we can, with these components, with Kafka, which is a very powerful engine, I would say, or a platform, with a connector, we could write it to where we want to. In between, we can capture all the changes. So we do CDC in CDC using Debezium driver over here. You can check it out, the details. So the Debezium driver, when it attaches itself, it actually gets the data, and then it will mark the operation with a code. And for the bulk operation, it puts an R, and for the insert operation, it puts a C for create, which is basically object that it creates. It's a sample data set over here. It's difficult to see, but I'll share the slides. I just wanted to show what the ecosystem works like. And then for the update, it shows U, and then it's an update for the delete operation. So this is actually the CDC. But capturing that and then storing that, and also on top of that, using it for BI, using it for data warehousing, or using it for other meaningful, effective business result is a different story. That needs to be on a proper store, that needs to be evaluated. So it could be also visualization, right? You might want to, live charts of all the things that are going through. From the industry, we've actually had very large gaming companies using these open source technologies. One of the things that was the most difficult to manage was the leaderboards. So leaderboards are actually for Call of Duty, for other Black Ops, other games. It's very difficult to capture, millions of people playing. And you could capture all that information with the up-to-date information. So from the connector side, from the Debezium driver, going from the source to your end data store, you have to worry about the data types. So the data types actually go into, there's a mapping for the data types, and then we have the supported data types, and then we also have data types that convert into a string. So what that means is, usually it's date, time, and some of the other text, and some of the other data types that are not like a very standard, they turn into a string. This means when you are on the destination data source, you have to handle that string into a meaningful data, which is possible by using the internal built-in database functions. So going back to the Debezium currently, from their website, currently supports all these databases. So we always talked about the open source OLTP databases, but as of today, it has GA level connectors, all these data stores. What this tells us is not only I'm worried about Postgres MySQL, say some sales application within an organization is using a proprietary software that used a SQL Server database. You can actually pull that data in also. So you can have multiple pipelines into the Bayesian driver to Kafka. This is how they do the data lakes from multiple source, and then write it to your destination source or state in Kafka. So there's also solution for Kafka and KSQL. We'll talk about that. They are saying it's incubating. I worked in this project for 2.5 years. Vitess, which is MySQL sharding framework. We have a talk about this in this afternoon. Matthias is going to talk. He works at PlanetScale. I actually was one of the maintainers of the Vitess project. It's a sharding framework. This Bayesian driver is actively being used in this framework, even though it's incubating. It's used in production. And it's used by one of the large transportation companies that does these e-scooters. Millions of them around the world actually sending IoT data, and it's being ingested into this framework using the Bayesian driver. Okay, that was enough for that. There's a very large blog post about it. There has been talks about the details of how it's done. But what I want to emphasize over here is the Bayesium is a proven technology in this type of solution. So the other operations that require some attention are on the Postgres side. There's date time and timestamp limitations. So when they turn into, I mentioned that you have to use some functions to that. There's some aggregate functions and stuff like that. There is a way to do that within the sync connector. We haven't solved all the problems, but we're very close of solving some of those challenges into handling like the Unix timestamp and then converting to more meaningful date time timestamp variables, and then we could do that. So going back from our workflow, the second step is the Apache Kafka. It's another open source distributed event streaming platform. So Kafka takes everything as an event, and it lets you publish and subscribe to those events. They call it a topic, actually. Each event becomes a topic, and then you could actually store within the Kafka, or you can process analyze within the Kafka. Or you could actually stream that to another data source. For our workflow, we will not stay in the Kafka. Nothing wrong with Kafka. If you're like familiar with the Kafka and the solutions, that is a very proven technology. And the use cases are mostly like data integration. So again, multiple source comes into Kafka, you get integrated, and then you becomes there's matrix and monitoring is a very use case, log aggregation, stream processing, and message broker. So these are the main use cases of Kafka. I am not a Kafka expert, or by no means. There are experts in this area, which actually one of the companies are Confluent, that does the support for Kafka, and I've actually marked this blog was very powerful and very detailed blog series with 4 parts. If you're interested in learning about, I'll share the slides, learning about Kafka and possibilities with Kafka, you should read this blog first and then drill down after that. So Kafka does one thing. Before we get to that, I'll summarize. I thought I had a slide on that, but Kafka is the data is another key value store. That's why it's very fast. One thing it does different than other key value stores, Kafka, that I learned is it does timestamp, key, and value, which makes this possible of streaming and subscribing, so it knows. So what happens is the Kafka runs like an LSN, and it knows where it stopped and what it processed and where it's left off. So it's got a timestamp based on that, and then it actually can track all that. So we go back to our streaming, archiving, and CDC. Let's talk about that a little bit here. So we have the source, and then we stage that information, and then we process that and then write it to our destination. So our staging area, in this case, is where we keep all the changed data coming from Debezium to Kafka. So at that point, you have already know what data changed within that given row. If it's not a change, it's a new insert. Insert is a create, which means a new object. So if you're only inserting data, then you don't need to keep track of the changes. But if your data is changing that you need to analyze and know what changed, you need to actually say that. This is very common solution for the organizations is the price tracking. For example, publish price, like a lot of the online e-commerce sites now allow third parties to sell. For example, Amazon, for example, eBay. People go out and sell. So take an example of I publish something, I want to sell a PlayStation 5, and I say, okay, it's $4.99. That comes with 2 controllers, okay? And I go and make a change, and I sell that to a number of people, and I go and make a change with a 1 controller. I don't send a 2nd controller. So that change can be captured within system like this immediately, and it gets marked as fraud, and that seller becomes banned. And so I also worked at eBay, so we've done that. A lot of the fraud systems worked on CDC. So use cases are many. That's one example. The other example I could give quickly over here is the sales and the numbers that you compare against the last year or last quarter. You know, how do you keep track of your last sales? And this is how it's captured. So you capture all the sales, create a summary tables based on days, weeks, months, and quarters, and then you can actually run a quick report against all that, and your CEO is happy in the morning. Okay. Kafka Topics also does the similar as what the Debezium publishes. So Kafka can actually understand the operation value and keep all that data. This is important for cities. If you're not doing this, you're not actually capturing everything. So that might be data loss. In this case, as soon as you attach to your source, and that is called a subscription, once you subscribed, you're not actually losing anything in between. Okay. So we'll come to this point of the last piece of our workflow. Over here, I'm going back over here in this one, before the destination, the sync connector. So what does sync connector do? It does actually subscribe to that Kafka topic that data was streamed into from using the Debezium driver. And then it understands there is a new subscription. If it's a new subscription, it goes and checks whether there is data already stored originally, and then it will start the bulk processing load. So in our use case, when we start something, there might be millions, maybe even billions of rows in your source table, okay? So how do you get that before you start streaming? Because once you start streaming, it's easy. You're gonna get as much changes or as much inserts that will coming from the source system. But if there is already a high number of rows in the source, you actually need to do a bulk load operation. So we have developed a bulk load technique that we can actually insert large data set into ClickHouse. And also we have done some work around the restart handling, because that can be broken. The streaming can be broken in between. So when you restart, it knows where it's left off, and that subscription continues from the point the last insert handled, which avoids the deduplication, right? So it handles the duplicate records. We usually do, I'll show you in our demo, hopefully we can do that. We usually do primary key on both source and destination, and that way we actually have a unique value for every row. And from improved operation of that primary key, the duplicate records will be rejected anyway, but in this case, when we actually restart, we don't actually have to do bulk load again, because if you don't understand where you left off, then every time it restarts, then you need to do a source and destination reload. Okay. So for the sync connector prerequisites, before we could actually run this, in the MySQL side, we have to have, of course, the logging enabled, and server ID and the bin log. And this is like standard for the replication for the MySQL. And that table should have a primary key. That way it works with the replacing merge tree engine of ClickHouse. So the replacing merge tree engine requires a primary key. And even though your source doesn't have one, you can add one primary key, and then you can add one primary key with the replacing merge tree. That way you don't actually have to do duplicate cleanup after the bulk load. Otherwise, you might be getting some duplicates, which is not the purpose of our streaming archiving data. On the ClickHouse, data type is a large integer is recommended, so it doesn't actually run out of the integer value. And the engine for the ClickHouse, of course, maybe audience is not very trained on ClickHouse, but ClickHouse is different engine types, and replacing merge tree engine can actually handle update and the inserts and deletes on the data in an efficient manner. We have some notes over here for Postgres and the MongoDB. Of course, both of them, same as MySQL, you need to enable the logging. So the logging allows the Demystified connector to capture all the changes and the transactions, and then streams it to Kafka, and then we connect to Kafka, we read that data, and then write it into ClickHouse. So also, we have some supported data types that are, we worked around these, and some of them, date time for Postgres, there's some challenges over here that was reported by some of the engineers I work, and we are working on it. Schema registry, I think this is to do. I will talk about that, and there's some discrepancy around the timestamp data type. So there is also the similar version over here for Postgres, and then if the data type is not the ones that are supported in the ClickHouse end, it will convert it into string. Nothing wrong with that. It's string, but string data type is something you have to, what is that called? Some assembly required once the data type is string. So from this, we could run it on a small data set, or we could run it large. I wanted to represent something that is with a large data set. There are many large data sets within the ClickHouse ecosystem that's presented. Something that I worked in the past, I said, okay, let's give it a try after some years. Airline on-time data by the transportation agency that keeps all the airline data, and it publishes on a website. You can download it and actually process it. So I'll talk about that a little bit. This was previously demonstrated on comparison between InnoDB and MyRocks in MySQL ecosystem, and then compared against the ClickHouse and the other data stores, and Hadoop, Apache Spark, and there were some other comparisons made in between. I've also based this on, again, Vadim's exploration. Vadim is the Percona CTO, someone I've worked in the past over many years. And he has done these exploration type of things back in starting in 2016. So it's got, I put the links over here. And that time when he actually originally tested this, ClickHouse was new and it only supported inserts. So hence, if your data store only supports inserts, there's no CDC. And we will bulk load data into MySQL. And we might skip that because of the time, and I'll show you how it's done, and then we'll attach the Demystified driver to MySQL, and then we'll read the Kafka stream, and then we'll let it do a bulk load to a ClickHouse, and then we'll query around and try to get some idea of what is the change, okay? So I
limited the objective of this demo to 3 pieces. Disk space utilization, how much it cost us in the source database, which is MySQL, and what is out of the box, what's it in MySQL. Query speed, of course, and other use cases that we want to do. So before we get into, I've looked at it actually. So there's out of the box, if I loaded 2018 and 2022, last 4 years of all the flight data within the United States, flight data means, I'll show you, it's a very, very large denormalized data type. It is basically tells where the airline is, where it took off, and then how long it took, and where it landed, and if there was a delay. So there's that kind of information is kept, and so this is like a single table. So our source is one single table, around 110 columns, with one single primary key. If we were to create multiple primary keys, multiple keys over here, then the size can be very large. And again, goes back to my analogy of handling that table within MySQL becomes problematic. And out of the box, ClickHouse actually stored this table around 2.5 gig of, so you will have savings around it. So this explains us a little bit of how better the compression is. I also tried the compressed data format of MySQL InnoDB. This is something I've loaded into MyRocks before. That had a similar compression ratio of like 25–30%, not as much as this one. So this one has a very high compression ratio. Okay, before we get into the all right, before we get into the monitoring piece, all right, so this will be available in GitHub repo, and we haven't open sourced it from the corporate side. So what I did is I cloned the repo into my personal GitHub, and I'll share the link over here, and you can actually download and test it. So we have actually on the README file we have 3 pieces. One of them is the MySQL, and the other one is Postgres, and these are also prepared Docker images, so you could bring it up on your laptop to test it out for a simple data set. But as the data set gets larger, both Kafka, MySQL, and ClickHouse requires more resources. Apparently, your laptop will not be able to process this type of data. So me and my team, we created 3 boxes on AWS, an EC2 box. And one of them we used it as for the Bayesian driver, the Kafka dataset, which actually gets processed, and our sync connector, which is a Python script. Okay, and the second box we dedicated to MySQL so that we can use it for MySQL and Postgres as a data store, and then we separated the ClickHouse. So there's no conflict of resources for these 4 or 5 components of total. So one source database, the Bayesian driver, the Kafka data store, the connector, Python script, and the destination is the ClickHouse in this case. So we go in. This is all shared in the README file, and what the first step on this demo is to load. Okay, 1 second. Here's my screen. Okay. Let's go back to the box. Okay. The first part is to load the data, and we will not spend time on loading data. I've explained that very easily over here real quick. So online airline data can be downloaded as there's a download script in my repo. I have the link over there. You put in the for loop of the tar.gz files, and then you get basically download that data. Again, it's free and it's by the government, so they don't even require any citation or trademark or something like that. So it's kind of a I like this one. Otherwise, so it's per month, and they are downloaded as zip file, and basically they come in the pieces, and in this repo that Vadim actually prepared originally has the MySQL and the ClickHouse directories. On the MySQL, you actually basically create the table that actually equates to this data set. It's a single table, 110 columns in it, denormalized, massively big, and you can go back in time of, I think, 1970s or something like that when they started. So there's a lot of data in it. And interestingly, you could actually query this and then come up with many different. So the government side actually updated since the last time I looked in 2019 when I was doing the MyRocks talk, and they have a better site, and that they have a query editor, and there's also visualization into the site. So you could actually do that. But we'll take that, and then we do load, which we don't need to worry about that because I already loaded this. You take that data set and then insert it into, it's a CSV file, bulk loaded into MySQL. And then as soon as you bulk load it to MySQL, I've made some tests over here, and I regular InnoDB compressed and with the primary key. So one thing that we added over here is to add a primary key. Well, who knows why do we need a primary key? Does anybody know why do we need a primary key? Well, Matthias knows, but the MySQL best practice is to have one primary key of every table. If you don't actually provide one or specify one, MySQL will have to create one in the behind the scenes to handle binary tree operations of the table. So, but it is recommended to have primary key on an ID field. We call it usually auto increment, unsigned big int, and then I can show you this table. This is the, can you see? Okay. This is the ID primary key that we added on top of the downloaded data. Well, the best thing is to create a table and then insert or alter the table after you insert. It might take a long time to do it. So we need this primary key. And what we do is, this is our data, and it's already loaded, so I'm not going to take time to load it. It takes about, 10, 15 minutes to load in this system. You could optimize it probably to make it faster, but this is a demo, so we're not worried about that too much. And then we go to the ClickHouse box. What do? We actually create the equivalent of that original source table into ClickHouse. Okay. And why do I have two? And then, of course, this was already run, but I'm going to show this one, show create table. And then this is the equivalent of the source table over here in MySQL in ClickHouse. That's where we are going to load into. And there's, of course, although ClickHouse has a very similar MySQL-like CLI, there are some differences between the engine engine types and basically some of the syntax that's different, but the table is same, 110 columns, and it will have 31 million rows for the last 4 years. Then we actually go into the Debezium instance, and then we log into Kafka, and we actually change the topic that we're going to attach into. So this is the properties file that needs to be changed. Okay. Yes, this is the one. Okay. Okay. And the file is called Debezium MySQL properties. That's not here. Where is that? Okay. We go into Kafka. And this is, I guess it's moved over here. Okay, this is where the script is. Okay. Right, I need to find out where this went actually, because we made some changes last night, but okay. Where is that? Using file. Okay, connect console sync corrector. Properties. Okay. Using file. SQL properties. Where did this go? Okay. All right, so this is how the Debezium connector works. It has the source and the destination, and we basically give the source of our MySQL box, which is this box over here, and then tell it the username, password, and provide all that information. And then this is our table, which I preloaded, and then we change the topic name over here, or give it a topic name. So the Kafka, the way that Kafka works is you can have multiple topics, and it can actually stream that information. So I'm going to change this one to live. Let's see if that works real quick. We're running out of time, actually. And then we actually check if there is anything running on this box. It is running, actually, so we kill this one, and so that we can actually register a new one. And then these are the Debezium driver. It tells what the MySQL properties are. Again, you can run multiple properties files with the multiple streams, but you need to make sure that you have enough resources to do that. And then it fails. Okay. It's a path issue, I guess. Yeah, it's well, we changed the paths last night. Let me see if that works, because otherwise it's in the, let me see.
Standalone properties. Kafka. Kafka new. I think it's a path issue. All right, we'll try again. If this doesn't work, I'll just go back to the way that it's already implemented, because the time is kind of running out. So, right. So I guess we'll leave that. I'll go back to that later on. And so going back to this monitoring, I want to wrap this up before. So we can actually have the Bayesian monitoring and the MySQL matrix that's collected. And we also have the Kafka topic can be done. These are all these components have exporters that you could actually pipe it to Prometheus and then graph in the Grafana, so you can actually have an entire workflow. We will publish that entire workflow of a dashboard that actually from your source to destination, what happened and how many topics went, how much data went through. And so in comparison, there's like bunch of example from the data set, example queries that average flight duration in this example was for the last 4 years. And this comparing the query in such way for like 30-something million rows, 100-something columns, very denormalized data, comparing from ClickHouse to MySQL is not even fair, because a simple select on MySQL, unless you have a specific index that is created for that query, in this case group by year, or month, you need an index, a covering index for this. Comparing with ClickHouse, this doesn't even make sense. So I stopped comparing because ClickHouse is by far fast. So this is where that blazing fast thing comes from. A simple query that will run on that data set, basically a full table scan. It's not even fair to compare apples to apples. It takes 3 minutes something seconds on that system. Yes, you can optimize. Yes, you can create indexes, but you have to pay the price of having those indexes and the space and the administration or maintenance of those areas. So, whereas even like on the next query, the number of flights per day from the year 2018 to 2023, which is 2022 is the last one that is published. The last 3 months weren't actually available. So day of the week, this query returned in 0.02 seconds. And that is insanely fast compared to, again, in MySQL, again, full tables, which is it's going to take 3 minutes. So it doesn't make, well, can I make this fast in MySQL? Yes. I would go and create an index on an order by column, which may or may not be used again for other than this query, because there's 110 columns. Can we create indexes for all those covering index? No. We can only do a timestamp or anything like that. So I think we're running out of time. Or endangered missing. We are getting an Amber Alert actually. Yes, it's something missing.
Okay, we'll wrap this up real quick before we run out of time. And again, another query. There's like 10 of them. There's multiple on the website. I have the links over here. You can go and run once you have this data. So the moral of the story over here is to use the data store that it's meant for. In this case, for large data sets, large tables, OLAP systems are not very useful to handle it in MySQL unless there is a very specific use case and you can actually handle that, and which you can actually archive that data and offload it from your MySQL and then put it on an archive data and put something in front of it and say, okay, if the query is having an older data, go to that table. We've done that in the past where there was no other. There's a Percona toolkit that can do this gracefully. You say, okay, take this table and start migrate it into another table. There could be another cluster, and then start deleting that gracefully so we have a smaller. When there's an optimization issue, then you actually have to kind of, because deletes aren't deletes in MySQL, it'll put a flag. You won't save any space unless you rebuild that table or run a dummy alter on it, which is another problem if the table got too big. So I've had tables over terabytes of data, millions or billions of rows in the past, and this is a very common MySQL problem that customers come up. What do you have a solution for this? There is an archive. There's an archive engine, storage engine, which is supposed to be optimized for unindexed data. You can migrate it into that. That's not very popular storage engine, so we don't get too much support on this. And again, in conclusion, go back to the appropriate data store. For the sync connector, the CDC feature is still missing, so we're not actually staging all the CDC. We are capturing everything and writing into the destination. So possible scenario would be put a staging table, which will be a duplicate of the target table, but will have all the changes. So you can technically see the before and the after images of all changes, which is very critical in the same schema tracking at the source. So what happens if my source table changed, which is possible? You know, somebody added a column to capture the geolocation, latitude and longitude, and I don't have that on my destination. So we need to capture that. There's a schema registry, basically. We actually attach a process that tracks the differences between these source and destination. Archival process is also missing. So say you have actually migrated the data, but you haven't actually deleted anything, didn't gain much. And also on top of that, one of the desires that we have is to put a proxy in front of it so that you can reroute the data. If the data is not recent, you want to put it on ClickHouse, or you want to read it from the other sources, Postgres or MySQL. And you can try it yourself. We have the repos over here. Thank you for everyone. And if there's any questions, I can take it. I think we have a lunch break right now.